Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is, good stones. So, basically, this is a medium level problem, and to be honest, it is a variation from AtCoder DP contest, the very first question that was the frog jump. But a good variation has been produced. Hi Vaibhav, hi Nakaj, hi Chandu, hi Rishid, hi Chetan. How are you? So basically today I was looping through the videos so that the number of live viewers would increase a bit. So I think we can get started. So let me just present my screen itself and I am good to go. Yep. It's okay. Fair enough. Yep. So let me just take the screenshot a bit from this point. Yes. So now it is told. So see, it is told that we are given a Mario game kind of thing. Okay. Suppose this is a given Mario where he has some steps to jump over it and he has to reach the end. So basically, this is a kind of game. So now here it is just written in some different manner. The geek is in a geek land which has a river and some stones on it. Okay. And then he can step on any stone. This is what was given. Okay. Each stone has a represented number on it and the value of exact step geek can move. So now it is told that each stone would have some values. Like in a Mario game, suppose I jump at this point and here it is written 1, so I would get 1 points. If I jump at this point, it is written as 2 and I would get 2 points. But here in this question, this is not the one that we are talking about. Here the variation is that if the given number in here is negative, okay, that means he can go back, okay, exact -1 from this point to -1 +1 this point, okay. Then suppose the given value at this point is 3, that means 1 2 3, so he would reach here. Okay, so now it might be a scenario that suppose it is given as, okay, 1 2 3, and suppose here it is written -3, here it is written 3. So if it is written -3, then at this point suppose 3, so exact 3 means I need to have exact 3. Okay, so I can't move less than 3, I can't move more than 3. As this is very important, so I would repeat it again. जो वैल्यूज है हमें एग्जैक्टली exactly उतने ही वैल्यूज जाने हैं. ना उससे कम ना उससे ज़्यादा. So it just means that suppose we are given 3 and I just move forward 3 step, and here I come across again my negative 3. So this is minus 1, minus 2, minus 3. Again 3, 3, 3. So as you can see, this is loop kind of condition where we are just going to an infinite loop. And we are told that the position which would lead us to infinite loops are bad stones, are bad stones, and the position which would allow us to reach the destination are known as good stone. Like suppose it is given as 1. Okay, it is given as again minus 1, and it is given as 2. So I can say that these two are the bad stones. Why? Because plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. But if I come at this point, then I can simply go to this side. So basically, this is what it is. And here it is told in this question. So in this question, we need to return the number of good stones. Okay, return the number of good stones. Okay, so let's talk about this problem. Okay, so now we can see that suppose if we have 2, if we have 3, if we have negative 1, if we have 2, if we have minus 2, if we have 4, and if we have 1. So now if I have used the example 3 and negative 3, and here 1 step, 2 step, 3 step, 3 steps in between. So now you saw me that yes, Siddharth, you told me that here it is 3, here it is 3. And again, in the next step also, I used plus 1, minus 1. So I can say that if x exists and if negative x exists, then obviously this is a loop kind of condition. But this does not only defines the loop condition. Yes, basically this is the most easy loop condition, that I would walk 5 step forward, I would walk 5 step backward. So I won't gain any displacement. Basically plus minus. So the change is zero. So I can say yes, this is a condition. But suppose negative 1, negative 2, and then positive 3. Sorry, positive 1 and positive 2 and negative 3. So here by looking at this condition, I can say that all the pair of values which are positive as well as negative, they are in the same distance, I can say that they are bad stones. बट सिर्फ यही बैड नहीं है, और भी तरीके के बैड हो सकते हैं. देर आर मेनी फॉर्म्स बैड स्टोन्स कैन एग्जिस्ट, लाइक positive 1, positive 2. The accumulation of these two can produce minus 3, and this can form an infinite loop. So negative positive x and negative x is not present here, so we need to think of something else. So when we see this question, we just say the positive and negative x. But here we can see an example which contradicts our conclusion. So now, am I clear with this point till this point or not? Am I clear with the question? Am I clear with the flow of this? I would repeat the same in Hindi so that people would have a better understanding. हमें बताया गया कि एक मारियो टाइप का गेम है और उसमें वैल्यूज है. अगर पॉजिटिव वैल्यूज है तो वो आगे जाएगा, अगर वो नेगेटिव वैल्यूज है तो पीछे आएगा. और हमें ये बताया गया कि अगर आगे पीछे आगे पीछे आगे पीछे चेंज हो ही नहीं रहा, मगर वो नेवर एंडिंग लूप है. जो आगे पीछे हो ही जा रहा है, उसका मतलब वो बैड स्टोन है. जो हमें आगे बढ़ के कंप्लीट होने दे रहा है, वो गुड स्टोन है. ओके, ये पता चल रहा है. Now we moved a little bit forward in life. Okay, now we saw that when it is negative 3 and positive 3, then we go back and forth, and we saw that these are bad stone. But not only these are bad stone, कुछ और भी bad stones हो सकते हैं, जैसे plus 1, minus plus 2 and minus 3. The accumulation of plus 1 and plus 2 is also plus 3. Okay, that is why it is. So am you clear till this point or not? Give me a quick yes or no. Hi Joel, for me it's not a morning, it's late. So Chandu, am I clear to you? Give me a quick yes or no that am I clear till this point or not. Yes, absolutely. The distance should be there. Okay. Yes, absolutely. Like the distance, like there should be two values in between. Okay. You can understand it. But I'm just saying about the concept. Okay. Fair enough. Now we need to think of something else. Okay. So now it might be a scenario that suppose this is -1. And so now we saw that the accumulation, like the sum of x, and if negative x exists, then we can solve this question. But then we saw something else. Like we saw that suppose this is +1, this is +2, and then and this is -3. And then we saw that suppose at this point this is 2, 1, 2, and at this point this is 1. And suppose at this point -9 is kept. So in this condition, if you go back, I can say that this is 1, 1 plus 2 is equals to 3, and then here -3. So the prefix sum of both of this would give me the answer. But now we saw here that even at this point also, this is still like 2 and 1 and then -3. 2, 1 and -3 is still a bad stone. Okay, 2, 1 and -3 is still a bad stone, but -9 exists. So there's something like we can't really do our work on the sum. So now every possible way to solve this failed. So now what we need to do is we need to try, okay, everything. We need to try everything. Okay. So we need to try everything. Now what I can say is that I would, so try everything means that this is a problem of recursion. This is a problem of recursion. So now we would talk about recursion. Okay, so now I can say that in a recursive approach, okay, I can say that suppose I would say that if current, like suppose I am visiting this path 2, 1 and -3. So if I'm processing this path, then I would mark it as 0, because I don't know that if this path is an infinite loop or not. Like suppose this is an infinite loop, 2, 1 and -3, two tiles in between. This is an infinite loop. Okay, yes, I'm visible. So, English, please, sir. I'm from South. Okay, 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 okay. I would do that. So, see, so 2, 1, and -3. I understand this. So, now if you see that, suppose I'm processing this path. So, if I'm processing 2 and then 1, then I can say till this point, this is not a loop condition. So when I'm processing, okay, when I am currently processing the condition of this, I would assign 0. That yes, this is not yet defined. Okay, I would assign 0. Simple enough. in the recursion. And when I have, okay, like suppose I have visited 2, then 1, then suppose here I have 5, and then I go out. So at this point, if 215 is present and I go out, then I would say that this is a good stone. Like if the current stone is good, we would return 1. If we are processing a path, we would just keep everything 0. Like the return value would be 0, and this is not yet processed. Okay. If it is a bad stone, the remaining one, if it is a bad stone, then I would return 2. Simple enough. If I'm processing, I would return 0. Okay, like still the value is not defined. If it is a good stone, then I would return 1. If I have decided that yes, again we are seeing the same result, then I would say that this value is return 2. Return 2 if we are on the same path, like same loop condition, again we are visiting. Okay, how we would say that this is a bad stone? Now let's talk about this also. Okay, so we would say this is a bad. We would good stone can be determined that I would reach the end. So when I would reach the end by recursion, I would return 1. Bad stone means that I am currently processing, that I am revisiting a processed path, a processed stone, revisiting a processed stone. Like suppose I started from 2, then I came to 1, and then I came to -3. Then again I'm revisiting it. If I'm revisiting a processed node, then I would say return is 2. So this is very easy if you just see it in recursion. If you see it in recursion, this would be kind of this thing. Okay, like if it is processing, then we would return 0. Like yes, this is the path we are processing. If it is a good stone, if we reach the end, we would return 1. So we can simply say if the current index is equals to n, we would return 1. If we are revisiting, like if the current node to be visited already has some values, okay, assigned, then we are revisiting it. So this just means 2. So now we would just see it in recursion. Basically, these are the 3 states, these are the 3 parameters we would just keep in mind. That 0 means processing, 1 means it is a good stone, and 2 means that we are revisiting it. Okay, and here we can say if it is -1, then still not decided, like we did nothing. -1 means did nothing. Yes, this condition I have just forgot, because we would directly memorize it. Why? Because recursion has a very high time complexity, and the range of this question is 10 to the power 5, so we would definitely get a TLE. So we would directly memorize it. There is no point in submitting and getting a -1. Okay, so now I would just quickly code it in simple language, like this is it. Okay, so now first I would code the wrapper function. Okay, because this is to be understood. So now we would say int rec. And what all things we need? We need the current index. This is all we need. Rest all condition can be copied from this point. Please remember this. Rest, like what current position we are at. Because current position defines everything. If we have reached the end, it is a good stone. If we are revisiting a particular visited node, it is 2. If we are moving forward, we would just assign it with 0. And if it is -1, that means it has not been decided. So now rest all the things can be copied from here, because we need to just see that what is the current values. That is why we need this. Okay. And the next thing we need is a DPI. Okay. So we would say vector, and to be honest, you don't really need the DP array. You can make it in the global space, but sometimes test cases are present. That is why not really moving forward with the global array. So now I would say that if the index is greater than equal to n, like suppose we have reached the very end or surpassed the end, Like suppose the last value was 3. So that means I can simply go out. There won't be any infinite value, no? So I can simply go out the loop. So I would say big O of n, or 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 idx, okay, is less than 0. What do we mean by this? This is a very important condition. Suppose we have 1, we have minus 5. So if we have minus 5, that means we would just jump out of the array. And here we don't have any values to jump back in. So if we jump out of the array in negative direction too, then also that is a good stone. Because bad stone is what? Bad stone means which would just give me the rotation in the same path only. That is a bad stone. Otherwise it is a good stone. Okay. So we would say if the index is just picking me up and throwing me in the negative space, I would just say yes, this is a good stone. So I would return true. But yes, this value would be true. Now just see. I would say that, okay, first this element needs to be processed. Okay. First we would process this. Okay. First we would just say or int like this index dp of idx. This is just like a visited array. Okay. If like let's say if the visited array of idx, let's not name it as the dp array. Let's say the visited array. Yes. So if visited array of this current index is not equal to -1, okay, then return dp of idx. What do we mean by this? Suppose -1 means we have did nothing. -1 means did nothing. But rest all the values means it is we have already decided what to do. Either it is in the processing state, either it is in the good stone, or either it is a bad stone. We don't need to take decision. So if visited array is not equal to -1, then return visited array of idx. That means we have already made a decision. Like a student came, okay, a student came to me and he told me, sir, I have already enrolled in a different course. So there is no point in me teaching him again. So if the student has already enrolled, -1 means did nothing, but he has done something. If he has done something, then just return it. Okay. So if we are coming at this point, that means that visited of idx is equal to -1. That means this is why we are coming at this point. This just means that we did nothing on idx. That nothing has been done on this particular index. Nothing has been done. So we need to do something. The very first thing we can do is we would just process. So we would say dp like visited of idx is equals to 0. Okay. And we would return the forward, like we would just process it. So if we are suppose we are saying that 1 2 5. So if we are jumping here, that means we need to move forward here. We need to move forward. Like if we are coming on 2, that means we need to take a jump of 2. So the answer would be rec of idx plus a of idx. Why? Because suppose this is just like a jumping jack. Okay. So suppose this is 1, this is 2, this is 3. Suppose I jumped to 2. Then if I jump to 2 and 2 is the value, that means I need to take a jump of 2 again. So if I took a jump of on idx and I have processed it, then the jump would be this big, idx plus a of idx. Okay. Then n would remain the same. Okay. And the visited array would also remain the same. Okay. And then this is done. Simple enough. Now we would say that vector int visited array of n with -1. Okay. And then we would say we would start from any of the points. Like the starting point would be first 0, then 1, then 2, then 3. We would start processing from every point. Okay, we would start processing from every point. For int I is equals to 0, I plus plus, and then we would say rec of 0 comma n comma a comma visited array, and then we would simply like initialize the answer is equals to 0, and then we would iterate over the for loop of the dp array. So we would say for int I is equals to 0, I is less than n, and I, sorry, for int I is equals to 0, I is less than n, and I plus plus, and answer plus is equals to dp of I. You can give a simple for each loop too, and that would solve the purpose too, and you can also use accumulate function. Okay, but I did the very basic one so that everyone would be able to understand. So now let me see. Okay, we need to comment this out also. So return dp, return. Okay, this will be good. Okay, I'm just writing dp every time. Did I miss something? Return of n and then a itself, and then the visited array. Your output is -3, and the output is first we would process each one of them. Okay, sorry, this would be I. Now just compile and run again. If I is greater than equal to n, return the value of 1, else visited array of idx. Okay, we need to just save it also. This is done. So now basically this is a DP problem. But even if you don't see the DP problem here, we can simply say that if you are coming out of bounds, we would return 1. If we have not visited it, like if we have like made a decision for it, okay, this is basically writing the recursive formula. Okay, so like if you just remove this part, okay, and if you just initialize the answer, int answer is equals to 0, I would say int answer is equals to 0, and return this. Okay, like answer, like simply do this. Okay, simply do this and make a visited array, and this is it. Nothing else. Just keep marking it. But this can't be solved fully by recursion. Like recursion would definitely give you a segmentation error, to be honest, because we need a visited array kind of thing even if you solve this using recursion. That is why, to give you a flavor of this using recursion, I used the visited array so that you would also have a proper understanding. But in every implementation you would find the name of the visited array as DP itself, like you see in daily problem. So now I would just share the tab and then you let me know at which point you are not able to understand. So good stones, yes, just tell me. So Santosh, Rishit, Chandu, Astha, am I clear? That means we are in a cycle. So we are not marking it as a bad stone. If so, why are we not? So a visited array is equals to 0. When visited array is equals to 0. So initially, देखो, I would just say it. Suppose let's say I saw a girl named as Ankita. I assumed that she is a bad girl. Then I saw good things about her, and then she became a good girl in my personal book of behaviors. Fair enough? So, in the same manner, first I already say that this is a bad stone. Then, if somehow I am able to reach the end, I would say that yes, this is a good stone. See, first I say that this is a bad stone, and this bad stone would only change if something from here tells me that this is a good stone. See, first I already assumed it bad stone, and this would only change if this value gives me 1. So this just means that first I'm assuming 1 to be bad stone. Then if by using 1 I can reach the end, then becomes a good stone. 1 means what? Good stone. No? 1 means good stone. 2 means bad stone. Just remember this. This could be done. Okay. Any more further queries? Most welcome. I deserve a chocolate from you. I deserve many chocolate from you, Rishit, to be honest. Okay. Any more concerns or queries you have? That is why we don't really need to assign explicit 0 to it. We already assumed it bad. If somehow it becomes good, then it is fine. Else it would remain bad. Okay, Astha, thanks a lot. Okay, so I think most of the queries have been answered. I don't see any remaining queries. So that's it for today. If you're watching the stream in the recorded version, feel free to just comment and like the video so the reach of this video could be increased. And if you face any issues regarding the question of solution, feel free to reach me out on LinkedIn. That's it for today. Thank you and have a nice day. Good night, everyone.